Chapter 32, Analog Braking, Vehicle Stability, and Collision Avoidance Systems. Day 1, Video 2, ABS Speed Sensor. So these are the components, the unique components to an ABS system. We've got the ECM, we've got a tone ring, we've got a speed sensor, and a modulator valve. So we're just going to concentrate on the two components here in the middle is the speed sensor and then the tone ring. Tone ring would be mounted on the brake hub so that as the tire and the hub is rotating as we're driving down the road, this is going to be attached to that so it's rotating at the same speed as the tire. Located somewhere on the brake spider through some mounts and mounting bosses, and we're going to have the speed sensor located here, so it's oriented almost in this shape, in this position here, so it's very close to that tone ring. So the tone ring has numerous teeth around it, usually right around 100 teeth, and then in between those teeth is an equal amount of gaps in between. So we've got a tooth, a gap, a tooth, a gap, a tooth, a gap, so on all the way around. So 100 teeth and 100 gaps. On the speed sensor, it's going to count how many times or how many teeth there is and how quickly that comes by that sensor. It's going to count that. So how the speed sensor works is it is a small alternating current generator. So inside here we've got a magnet, and then we've got a coil of wire wrapped around the outside of that little magnet, and then with one end of that coil of wire coming up here with a terminal end on it, going through the speed sensor, then the other end of that wire coming out to another terminal, and then those going back to the ECM. So how we use this to create a signal is we've got that magnet, so we've got a magnetic field and then a coil of wire around it. So what we're doing is generating a alternating current voltage, and how we do that is we have a magnetic field, we build it and collapse it through a coil of wire, and that induces a voltage into that wire. So what we're doing here is we've got the speed sensor located close to the tone ring, and every time one of those teeth comes by, it changes the field strength of that magnetic field. Starts to build and to build and build. Then as the tooth passes by and starts to move further away, our AC voltage reduces or collapses, right? So we're constantly building a alternating current signal. So the tooth comes in, the magnetic field builds, the tooth comes by, it collapses, and we create a small alternating current voltage, or a spike, or a pulse, we'll call it. The gap comes by, the next tooth starts to get close to the sensor, the magnetic field builds and builds and builds, right? We're right by where the tooth is at, we're at our maximum strength of that magnetic field, and then it passes by, and now it's in the middle of the gap between this tooth and the next. Magnetic field collapses, another spike or another pulse, right? So that's how that speed sensor works. Much the same as any engine speed sensor, camshaft speed sensor, that sort of thing. So this is kind of a representation, the alternating current pulses, the graph that those are produced, or graphically representing that. The top here being the tooth as it's passing by the speed sensor, and the low part here, or the part in between, is the gap that's in between those teeth. So here we've got a spike, or a pulse, 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 right? So it's counting those teeth as it's moving past that speed sensor. So representation we've got on the bottom here is a lot more rapid, right? So you'd say that this one on the lower side here is traveling past that speed sensor at a lot higher rate of speed. So we've got low voltage up to high, back down to low, up and then down, up and down. So pulses as it's going by those teeth. So that way the ECM can tell how quickly that that tire is turning. Kind of review here the reluctor wheel, or the tooth wheel here is passing by the attached to the hub. Speed sensors mounted to the brake spider, and then the speed sensor has a magnetic field that's broken as the reluctor wheel passes by it. That creates that pulse. So we also call the speed sensors a pulse generator. That reluctor wheel has 100 teeth and 100 gaps in between those teeth, so that we are getting 100 pulses per wheel revolution. That top pattern, we could see that that it had that was a lot fewer spikes there. We could say that that wheel is rotating at a lot slower rate than the bottom pattern. All right. ECUs can receive those signals at all times. Even if we're not in an ABS function, it's still monitoring and reading those pulses from each speed sensor. Example here with the two patterns are steer tires. The one on the top is ready to lock up. We're driving down the road at 60 miles an hour, and it's seeing a lot slower rate on one of the steer tires, than the other one. Logic would tell us that this tire is locking up.